This video will focus on the content. I can compare atomic and ionic radius of atoms. So when we talk about atomic radius, what we're talking about is the distance from the nucleus to the outermost stable electron orbital. So that's when you draw its electron configuration. Those electrons in their ground state orbitals from the nucleus out there, that's how they do it. A lot of times we can't do this actually by measuring a distance because we're talking microscopic things. We can visualize atoms. So sometimes when they're bonded, that's when we do it, which means it's 1/2 the distance between the two nuclei in a crystal. So one of those two methods is usually used to find the atomic radius, which again is the distance from the nucleus to the outermost valence electron. So if you look at this picture, it kind of shows the two different ways you can potentially figure out what that distance is. If it's actually bonded covalently, which is a sharing of electrons, it's a little different than if they're charges. So for this video, we're supposed to focus on what's the difference between the radius of an atom and the radius of an ion, because they are different. So why would creating an ion out of an atom change the radius? Well, when you think about it, the distance from the nucleus to that outermost electron, that distance is dictated by the attraction of the electrons toward the nucleus, and then also that repulsion of the electrons on each other. So when you make an ion, either you gain electrons or you lose electrons. And it's all about that balance between the push and the pull to what the consequence is to that change. So if you look at this image, it shows some of the changes and how the size of the atom's affected. When lithium becomes a positive ion, it gets smaller than it was before. When beryllium becomes a positive ion, it gets smaller than before. But then for fluorine and chlorine, which is they gain electrons instead, they do the opposite. They get bigger. So this is a consistent pattern. We see when atoms lose electrons, they become smaller. And when atoms gain electrons, they become bigger. Okay, so cations are going to be smaller than their neutral atom, and anions are going to be bigger than their neutral atom. When you think about why that happens, for cations, when you're losing electrons, if you think about that balance between the repulsion and the attraction, you're losing repulsion because you're losing electrons. So essentially that effective nuclear charge increases because we have less electrons feeling the pull of the protons, and so you're going to be pulled closer. The other thing that tends to happen, depending on the ion, is you might lose an entire sublevel, like an entire S level or an entire P level. And if that happens, you're actually losing that outer distance. Like those are the furthest away from the nucleus. So if you lose all of them, of course you're going to be closer. But then not only are you going to be closer, but you're going to be pulled in because of that effective nuclear charge's distribution on all the electrons that are left. For anions, on the other hand, which are atoms that are going to get bigger than their neutral atom, we're gaining electrons. So in relation to that push and pull, we have the same effective nuclear charge. We're not changing how many protons are present, but we're increasing our repulsion. So the fact that the electrons are repelling each other to a greater degree, we have the same pull in, but more repulsion, so those electrons are going to spread further out. So anytime you gain electrons, you end up becoming bigger in size than without them. And whenever you lose electrons, they become smaller. That's it. Have a nice night.